pulverized coal is the fuel used predominantly in reheating furnaces in the steel re-rolling mill sector. Higher the calorific value of pulverized coal, lower is the fuel consumption in the furnace. The calorific value of any fuel can be determined in a laboratory using a bomb calorimeter. Generally, the gross calorific value varies between 4800 and 7200 kilocalories per kilogram. The major parts of a bomb calorimeter are an outer copper shell called calorimeter and the inner shell made of stainless steel where the fuel burns called bomb. Two fuse wires made of magnesium fixed to a 6-volt battery are used to ignite the fuel. A channel for the supply of oxygen is placed to help the burning of fuel. The steel shell or the bomb is enclosed inside the copper calorimeter. The calorimeter is closed from top using a copper lid. The space between the calorimeter and the bomb is filled with water. A mechanical stirrer is placed and on the opposite side of the stirrer, a thermometer is installed. The calorimeter is enclosed inside a capsule with an air jacket between the inner shell and the calorimeter and a water jacket between the inner and outer shells. During the process, fuel of a known quantity is placed inside the bomb and ignited. The bomb is filled with excess oxygen at 25 to 30 atmospheric pressure. The heat generated in the process is dissipated to water present in the calorimeter chamber. The mechanical stirrer is used to maintain a uniform temperature of the water. The amount of temperature rise in the water is noted using the Beckman thermometer. The gross calorific value or GCV of the fuel is achieved by the following mathematical process. Add the mass of water present and the water equivalent of the instrument. Water equivalent is an assumed value which assumes that the bomb is surrounded only by water, and it also assumes the amount of heat absorbed by water in this condition. Subtract the maximum temperature of water from the initial temperature of water. Heat absorbed by the apparatus would be determined by multiplying the results. Heat absorbed is equal to heat liberated by fuel. Gross calorific value or L is determined by dividing the result by the amount of fuel taken in the bomb crucible. Some subtractions are done in the above formulae. The heat dissipated from the acidic reactions, the calorific value of the cotton, the fuse wire used to ignite the fuel. At last, the rate at which the metal cools needs to be added. Thus, the formula looks like this, and the net calorific value NCV equals GCV minus 0.09 H into 587 calories per gram, where H is equal to the percentage of hydrogen in the fuel. The advantages of in-house test facility for gross calorific value are: actual GCV of the fuel can be determined and cross-checked with the test report provided by the supplier. Poor quality of fuel can be rejected. The amount of air required for combustion can be pre-calculated theoretically based on GCV of fuel. Specific fuel consumption can be reduced substantially using good quality of coal. A bomb calorimeter can be effectively used for determining GCV for effectively any solid or liquid fuel. Normally, bomb calorimeter of this size would cost around 50 to 70,000 rupees.